Hello everyone, welcome back to mahafarka.co.in. In this article, we are going to discuss about drops and bubbles. Ordinarily, you must have easily seen when tap of your water tap is leaked, then water is when it is falling on the surface, it automatically acquires almost a spherical shape. When you blow the bubble, how soap solution, if you have deep ring into the soap solution, if you blown, then bubble is formed. That bubble also occupies which shape? The spherical shape. So when it occupies the spherical shape, it is important to study what is happening with the pressure inside and outside that bubble or drop. So in this article, we are going to derive the same expression for pressure. Okay. So to find the pressure, let's consider drops and bubbles. The formula what we are going to derive here is also called as a Laplace law of spherical membrane. So to understand that, suppose I had drop of radius r. I am having drop of liquid whose radius is what? R. So I will write simultaneously, let R be the initial radius of drop. Now I had applied little force so that the volume of that drop increases, so that its size also increases. In short, its radius also increases by small extent. Say radius of the drop has been increased by small extent. Say this amount of radius which is increased here, it's very small, it is delta r. So let delta r be the increase in a radius of drop. Before increasing in the radius, say Pi be the pressure inside drop, and finally Po is the pressure outside drop. Pi is the pressure inside drop and Po is what? Pressure outside drop. How will you find the difference in the pressure? I will call that excess pressure. Before that, you have to conclude which pressure will be more, Pi or Po. Remember, according to Boyle's law, if you remember, smaller is the volume, larger is the pressure. Pressure and volume are inversely proportional to each other. So drop has very small volume as compared to the surrounding. So pressure inside drop will be large as compared to that atmospheric pressure. So here Pi minus Po, I will call it is what? Excess pressure. It is called as what? Excess pressure. Say this is equation number 1. Now few things that we are going to write here that already we are knowing already. We have the formula for work done in terms of surface energy and increase in the surface area. So I will write few things first. So initial surface area A1, before increasing the radius, its value is what? R. So spherical drop has surface area कितना होता है? Pi r square. Final surface area will be A2 equal to 4 pi. See now, radius has been added, R plus delta R, no? So radius increase by delta R and its square. So what I will do is, I will just simplify this bracket. So 4 pi R square plus 2 times R into delta R plus delta R ka square. I will multiply this, so it will be like 4 pi R square plus 4 pi into 2R means 8 pi R into delta R plus 4 pi delta R square. See, this is equation number 2. Now, in initial है, final है, how to find the change in the surface area? Change in a surface area, say dA is equals to, how to write? You know that it should be definitely final surface area minus initial surface area. Substitute the values. याच्यातनं याला मायनस करायचं आहे, इनिशियल सरफेस एरिया बघा, याच्यातनं जर याला मायनस केला तर काय होणार आहे? हा 4 pi r square कॅन्सल होणार आहे. डायरेक्टली काय राहणार आहे? ही एवढी टर्म राहणार आहे. सो 8 pi r delta r plus 4 pi delta r square. So see, here the value of delta R already in the initial stage I told you that it's very small. As it is very small, since delta R is very small, that square of delta R will be again become smaller. So neglecting delta R square. So what equation 4 will be there? Equation 4 will change to then what? Therefore, dA is equals to, if I neglect this, then what we will get? 8 pi r into delta r. So this is equation number 5. Then we know that work done during this is given by, how to write work done? If you remember, dw equal to t into dA. Substitute value of dA. So it is t into, what is dA? Then I will write 8 pi r into delta r. So this is equation number 6. T into 8 pi r delta r. Say this is equation, instead of 6 I will call this is capital A equation. So now this was in terms of surface tension. But now mechanically we have increased the area, so we have to consider mechanical work done also. We know that what is mechanical work done? Mechanical work done in the process is given by dw equal to delta f into delta r. Radius changes by delta r and applied force is equals to what? Delta f. But what is the formula? But by definition, pressure, or instead of calling only pressure, I will say it is which pressure? Excess pressure. Why it is excess? Because this much of force is required to change this pressure. So I will say excess pressure equal to delta f upon surface area, that is 4 pi r square. So what is delta f equal to? Excess pressure. What is excess pressure then? Pi minus Po. So Pi minus Po into 4 pi r square. See, this is the value of delta f what we got. Let's substitute here in equation number 6. What we will get then? Therefore, dw equal to Pi minus Po into 4 pi r square into delta r. Say this is equation number B. See, equation A and equation B both represents work done. First equation represent work done in terms of surface tension. Second equation represent work done in terms of the applied force, mechanically what work we have done. So both are representing the same quantity, so we can equate them easily. So on equating equation A and B, what we will get? Let's see. Equating this equal to this. So Pi minus Po into 4 pi r square into delta r equal to this one, t into 8 pi r into delta r. So now see what is cancelled? Delta r to gaya, pi get cancelled. This 4 and this 8. So here 2 is going to remain. Okay. This r and this r square. So this r is going to cancel. So this r is going to remain only here. So if I write this term again, Pi minus Po into 4 is already cancelled. So r equal to only 2 and t is remaining. So Pi minus Po equal to 2t upon r. Pi minus Po equal to what? 2t upon r. This formula is also called as Laplace's law of spherical membrane. This formula is also called as what? Laplace's law of what? Spherical membrane. Now this work we have used for drops. For drop. Okay. Now for bubble. Now what change in the surface area of the bubble is going to take place? You have already learned in this derivation initially. So when bubble is considered, then outside bubble also one surface outside bubble, and one surface inside bubble. So this change in the surface area, here instead of 8 it will be 2 times. So when I multiply it will be 16, and then initial surface area will be 8. So in very simple words, this 2 for bubble will be 2 times. So for bubble I will write Pi minus Po equal to 40 upon R. This will be the formula to find excess pressure inside drop. This will be the excess pressure for bubble. But now, if suppose this is water, means any liquid is there, and then bubble is formed inside the water, then this surface should not be considered. For that case, you are going to write it 2T upon R. This is very important. If bubble is formed inside liquid, so surrounding of bubble is not air, instead of that it is liquid, then you are going to use this same formula. Okay, I hope you understood this article also. This is again one of the important article for CET. Thanks for watching mahafarkar.co.in. Have a nice day. Thank you.